Hi, I'm Sydney Kiedeisch from your 10 o'clock class, and today we're doing an optimization problem. The problem is as follows. You work for a publishing company trying to save money on a reprint of a popular movie poster. The image takes up 32 square feet. The surrounding frame is 1 foot on the top and bottom, and the frame is 2 feet on the left and 2 feet on the right. What should the movie poster dimensions be to minimize the poster materials used? So the first step we're going to take is to draw a picture for this. We are going to need to have all of the things that were included in the problem. So the image itself is going to take up 32 square feet, which we wrote right there. And then you need your x and your y axis. We're going to have the y be the top and bottom, and the x be both of the sides. And we know that there's 1 foot on the top and bottom, and 2 feet on the left and right that need to be blank. Your picture should look like this. The first equation that we're going to need is the constraint equation, which gives all of the... So we have 32 feet as the area that we know, and the x and the y. We know that the x and the y together have to equal 32 feet squared. Next, we're going to write down our objective equation. This is the equation that, with the knowledge that we have, plus the add-ons, that is how we're going to get our answer. So we have to do A equals the x plus the modifier and the y plus the modifier, which is the margins on either side of the movie poster. For the next step, what you're going to want to do is substitute out so you have the equation all in the same terms. And how you're going to do that is to go into the constraint and make the equation equal to one variable. I've chosen y for this. You could have chosen x, but I like doing the y. So you do A equals the x plus 4, and then replacing the y with the equation you just made, 32 over x, you add 2. Next, what you're going to do is to distribute all these numbers out. So you do x times 32 over x, which cancels out in 32. X times 2 is 2x. 4 times 32 over x is going to be 4 times 2 is 8. What you're going to want to do after this is to simplify the equation because you have like terms that are not put together yet. Awesome. And now you have to derive. So finding the first derivative, you have to find the derivative of each of the terms because they're added. Right, and so that's what you have. Then you're going to want to set the equation that you just found equal to 0. You do this in order to find the critical numbers. Now, solve for the zeros. And your zeros are plus or minus 8. The next step that you're going to do is take the second derivative. The reason you take the second derivative is to find whether or not you have a concave up or concave down with each critical number. And for this problem, since we want to find the minimized poster material, we're looking for a minimum, which is what the concave up and down tells us. So find the second derivative, and then plug in both of your critical numbers. So our x is going to equal 8. We found that out because the concavity is upwards, which is going to give us a minimum. So you're going to take the x as your next step and plug it into your constraint equation so you can find the y. 32 divided by 8 equals 4. So that's going to be your y. Now, what you're going to have to do to make this equation complete is add 4 to the x and then add 2 to the y to get your final answer. So the final dimensions are going to be 12 by 6. And that's the end of the problem. Congrats!